If you look at fructose 1,6-bisphosphate, which is highly more active than the fructose 6-phosphate because of the presence of the two phosphate molecules. Remember, we said earlier on that the phosphate molecules, the main role is to bring instability or to make our 6-carbon molecule highly unstable. So when we go to stage, the next stage, stage 4, we are going to have the splitting, or we can call it the cleavage of the fructose 1,6-bisphosphate. And this cleavage is going to be, we're going to have a cleavage whereby the two molecules which are going to be produced, each molecule is going to be holding a phosphate group. Each molecule is going to be holding a phosphate group. That's why we had initially two phosphate groups on the fructose, and this cleavage yielded two molecules, that is glyceraldehyde 3-phosphate with one phosphate molecule, of which that phosphate molecule is attached onto carbon atom number 3, and then dihydroxyacetone phosphate. Dihydroxyacetone phosphate is an isomer of glyceraldehyde 3-phosphate. So in stage number 5, we can have isomerization of the dihydroxyacetone phosphate to form a second molecule of glyceraldehyde 3-phosphate. Why? Because glyceraldehyde 3-phosphate is the one which is needed in the pathway of glycolysis. So we don't need the dihydroxyacetone in the pathway. So it implies that we had our first molecule of glyceraldehyde 3-phosphate, and then another second molecule of glyceraldehyde 3-phosphate is going to form from the dihydroxyacetone phosphate. Hence, we are going to be having now two molecules. At this stage, we are leaving the preparatory stage, the stage which we are preparing our glucose molecule for the next reaction. In the preparation for that glucose molecule, we realized that there was phosphorylation taking place. Why was it there? To completely make the 6-carbon molecule highly unstable, because we know very well that glucose is highly stable. And when it is highly stable, then it implies that the reactivity is going to be very low. So we are entering into the payoff stage. Payoff stage is like you have started working in the morning, then in the evening you are paid off. Though before getting to work, you invested some little money, maybe the transport money, and we are calling that the ATP. That ATP which was used, okay, part of the ATP was used, and only one phosphate molecule was utilized in stage 1. Another second molecule was utilized in stage number 3. So we had investment, energy was invested. So if you make an investment, you expect an outcome. So once you put in transport to go to work, then you expect some payment at the end of the day. It can be at the end of the day or at the end of the month. So we are getting to the payoff stage. So ATP has been utilized. So what is going to be paid off at this stage? So entering stage number 6, from stage 5 up to 10, we said that the payoff phase starts from there. The payoff phase starts from there. That is, we are going to see how much ATP is yielded and other molecules. So in stage number 6 up to number 10, we are going to be seeing two molecules of each compound that is there. Two molecules of each compound that is there. Why? Because the glyceraldehyde 3-phosphate was one molecule. Another molecule was isomerized from the dihydroxyacetone phosphate to form a second molecule of glyceraldehyde 3-phosphate. In other sources, you'll find this one made separate, whereby glyceraldehyde 3-phosphate is used here, and then at the same time here, and then it is being run 2 times. This side, the cycle, the steps are being run 2 times, this side and then the other side. But now I'm just combining it at a go. I'm showing that each molecules you're having 2 molecules of each, indicating that there was isomerization taking place. So the reversible reactions we are seeing here is that where we are seeing 2 arrows, it implies that the reaction can go backwards in case you reverse maybe the conditions. In case you reverse the conditions, the reaction can go backward. So we can begin on stage number 6, where having the payoff. So we're having an introduction of the inorganic phosphate, two of them, because they are getting the two molecules of glyceride 3 phosphate. So the inorganic phosphate, its role is to increase the instability of the molecule of glyceride 3 phosphate, and then we are going to form 1,3-bisphoglycerate. 1,3-bisphoglycerate is it has been what has taken place there. Hydrogen has been removed. So by NAD is this NAD which is having a positive sign has been oxidized. This NAD which is having hydrogen is reduced. So some hydrogen was removed from glyceride to form 1,3-bisphoglycerate. Remember, where is the second phosphate group coming from? It is coming from an inorganic phosphate. Someone may wonder, why don't we use ATP? We don't use ATP because we need to conserve energy. We need to conserve energy, and we don't want to make this as a loss, a process which is just giving us a loss in terms of energy. Already we have invested 2 ATP molecules, so we don't need to invest more. So we need to have an alternative where we can get the phosphate molecule, and that is the inorganic phosphate. Anyway, where could be the energy that is being obtained so for this reaction to take place? The oxidation of glyceride 3 phosphate to 1,3-bisphoglycerate releases energy. So that energy which has been released, it helps in the reduction of NAD, which is NAD plus to NAD with the hydrogen molecule. It also helps in the bonding of the of the phosphate to this molecule here, which is bisphoglycerate. So this phosphate group gets to carbon atom number 1, forming 1,3-bisphoglycerate. So we are looking at stage number 7, whereby now we are starting to obtain energy. Remember, there are 2 molecules. Each molecule is going to yield 1 ATP. So 2 ADP molecules come and pick up 1 molecule of ATP, 1 molecule of the phosphate group to form 2 molecules of ATP. Remember, why are we forming 2? Because we're having 2 molecules of 1,3-bisphoglycerate. So the phosphate group from carbon atom number 1 is going to be added to 1 ADP of 1 bisphosphate from 1 bisphosphate group, and then another phosphate group is also going to come from this molecule. It gets combined to another ADP to form 2 ATP molecules, like that. So we're having 2 ATP energy released here at this stage, and there are 2 ATP molecules which have been produced. So once the phosphate group of carbon atom number 1 is lost to form 2 ATP. Of course, why forming 2 ATP? Because there are 2 molecules which are here. We are going to remain with only phosphoglycerate with a phosphate group attached to carbon atom number 3. So of course there are still 2, as we said earlier on. So we are going to have isomerization taking place. This stage is reversible still. Isomerization. Oh, stage number 7 is irreversible as long as the phosphate group is lost. So the reaction cannot be reversed back. That's why I'm using a single arrow. So in stage number 8, we're having isomerization taking place, whereby there is a shifting of the phosphate group from carbon atom number 3 to carbon atom number 2 to form 2-phosphoglycerate. Of course, still the 2 molecules are going to be still retained. And then in stage number 9, we are having dehydration. That stage is the dehydration stage, whereby 2 molecules of water are released. So when 2 molecules of water are lost, what are we going to form? We are going to form phosphoenolpyruvate. Phosphoenolpyruvate, still we're having 2 molecules of phosphoenolpyruvate. In stage number 10, we are going to have more 2 ATP molecules formed as a result of 2 ADP molecules being phosphorylated, or getting 2 phosphate molecules from 1 phosphoenolpyruvate and another phosphoenolpyruvate. Remember, there are 2 form 2 ATP molecules, leaving us with a pyruvate. Of course, we are going to have 2 of them, of which these 2, each of them is going to enter the next stage, that is the Krebs cycle. So what should we know? What should we note here? We should note that how many ATPs were invested in the process. There are only 2 ATPs, that were invested, we can get back to stage number 1, that is 1 ATP.